Okay, so in this investigation, we're going to be looking at the graph of sine under various transformations where we have a horizontal stretch factor or compression factor. And what I mean by that is the graph that you see before you, okay, this sine graph will either be compressed or stretched horizontally. So that'll be along the x-axis, okay? Before we've looked at previously, vertical stretches and compressions and what that does. Now we're going to be looking in another plane. So before I begin, I just want to correct something here. I should be looking at B over here. So if you take a look at right here, I had an A. I'm going to replace that with a B so I'm consistent because I do have a B in my equation. And we're only graphing sine. The same rules apply to cosine. So let's take a look at that. You'll notice that I have a base graph for sine x, and over on the right-hand side I have a table of values where x and sine x are listed, and then I'm going to vary b where b is 2 over here, b is a half, and then I'll have b to equal -1. So let's take a look at each of the following values of sine under these transformations by filling out the table first. So I'm going to start off with this guy here. I'll highlight it in red. Be looking at sine of 2x. Okay. And since I'm in red, I will use my red pencil. So if I do 0, so I have sine of 2 times 0. Well, that's going to be sine of 0, which will just be 0. So my first value is 0. If I replace that with sine of 90, so I get sine of 2 times 90. Again, I'm just using the second value here. I used 0 beforehand. I'll get sine of 180, which is also 0. And finally, if I do sine of 180, and I say finally because I'm going to stop at this point, I'll get sine of 360, which is also 0. So I get 0 here. Maybe you may be wondering, like, well, what's going on here? I mean, I'm just getting zeros upon zeros upon zeros. And if I go to my graph, let's scoot in over here. Let me plot those first 3 points, okay? Use a slightly larger dot. So sine of 2x when x is 0 is going to be over here. When x is 90, I'm going to have a 0 again. And when x is 180, I'm going to have 0. So it kind of looks like, well, is our graph even moving? And what you'll notice is that it is. It's actually being compressed by a factor of 2. It's just that we haven't really seen any of that, figure out in our, table of values here. Let me just zoom in on the graph. Remember, we're looking at sine of 2x. So sine of 2x. Let's pick a strategic value, say over here, 45 degrees. So if I do sine of 2 times 45, that'll be sine of 90, which will give me not 0, sorry, that'll give me 1. So when x is 45, the y value is 1. And you can guess at this point that when x is halfway between 90 and 180, that's 135, you're going to get a value of -1. And again, if you don't believe it, plug it into your calculator and you'll find that sine of 2x when x is 135 will give you -1. Just get rid of this here. So what do we have? Well, if we connect these dots in a nice smooth line that curves, we're going to get something like this. In other words, you're going to notice that you have the same graph as before, except that it's being compressed by a factor of 2. Okay, so sine of 2x actually compresses our graph by a factor of 2. Let's just write that in over here. So we'll do over this. So we'll have compressed by a factor of 2. Okay, well, the 1/2 sine of 1/2 x, which will be in this pink color here, this guy over here. Well, let's go to the table of values, see what we get. And we will use a pink color. So sine of 1/2 is 0, well, that's going to be 0. Sine of 1/2 of 90, so if I go sine of 1/2 times 90, that's going to be sine of 45, which if you go on your calculator, you could probably do that. Let me do it here. Sine 45 will be 0.7. So I'm going to have, that's an estimate, 0.71 if you want. Sine of 180 is going to be, sine of 1/2 of 180 will be sine of 90. 1/2 of 180 will be sine of 90, which is going to be 1. Okay, I'm going to stop there again because I think you will see what the pattern is. You'll notice that I have very little. I have 0, 1.7, 0.71, and then 1. Well, what does that look like? Well, let's go back to our grid. Use a slightly larger dot here. So sine of 0 is 0, 1/2 of x, 0. Sine of 90 is going to be 0.7, so that'll bring me 1/2 of 90, it'll bring me roughly over here. And then 180, that'll bring me up to 1. Now 270, you can plug it in. It'll be half of 270, which is 135. It'll be about 0.7. 360 will be back down to 0. Then we're going to get into higher values because we actually haven't done one cycle yet. 450 will be like negative 0.7, which was roughly here. 540 will be negative 1, which is roughly here. 630 roughly here. 720 roughly here. And you can see why at this point we have such a large x-axis, because in order to fit in one cycle of this guy, we have to extend our graph quite a bit. I'm going to actually shrink this for the moment. Just put it over here. We'll maybe come back to it later. So what we get is a curve, a long curve that goes up, comes down, and goes up again. And I kind of missed this point over here. Let's fill it in. You get the idea. So what do we have here? Well, we have a stretch by a factor of 1/2. Now, sometimes you might see that it is also a stretch by a factor of 2. That's just because it's the reciprocal of this, and vice versa. You might see this as a compression by a factor of 1/2 because it's been reduced by 1/2. Again, textbooks have their own conventions. Stick to one, what you're more comfortable with. Finally, we're going to look at what happens when we multiply the x value by negative 1. And I'm going to go back to my table here. Open this up a little bit. Just bring this over here. So we have negative 1x. Well, when x is 0, by the way, let me use a different color. Let's say blue. So I'll be in blue. A blue marker. When x is 0, sine of negative 1 times 0 is going to be 0. When x is 90, sine of negative 90, that gives us negative 1. Again, if you're not sure about that, go into your calculator, type in 90, negative, and then take the sine of it, you'll get negative 1. 180 will be 0 again. 270, I promise you, will be 1. and 360 will be 0. And I think at this point you kind of see what's coming. Again, let's use larger points. So sine of 0 is 0. Sine of 90 will be -1. Sine of 180 will be 0. Sine of 270 will go up to 1. And sine of 360 will be 0 again. And with a smooth line, steady hand, I'm going to connect these points. I'll try that again. This is terrible. Let me go backwards. Try again. There we go. So the blue line is basically the original sine graph. I'm just going to quickly get rid of the purple and the red. It's the original sine graph reflected in the x-axis. In other words, that negative in front of the x, all it does is it reflects the graph in the x-axis. I'll put these back and just write that in over here. Say reflection in x-axis. So there you have a host of transformations, scaling the graph, either reflecting it, shrinking it, compressing it, or stretching it out. And that's all the b value right here, which has that effect.